Hello Year 10 and welcome to today's maths lesson for your home learning. This week we have been focusing on algebra and looking at solving quadratic equations to start with, moving into factorising, and today we're going to be looking again at quadratic equations and solving some slightly more complex ones than the ones we saw in lesson 1. At different points in today's lesson I may ask you to write things down into your book. You may want to use a whiteboard at times, and every now and then you may like to check your answer on a calculator. Can you please make sure you have that equipment in front of you? And when you are, we can start today's lesson. Okay, to start today's lesson, can you go ahead and pause this video and have a go at these questions and come back when you're ready to go through some of the answers? Okay, for question 3, I'm going to look at 3 and 4 today. Now, we did have a lesson yesterday on factorising quadratic expressions, and it's going to be an extremely important skill to use today. So to start with, I want two numbers are going to multiply to equal -5, so multiply to the end, but I want them to add together to equal -4. Those signs are really important here. How am I going to find two numbers that give me a negative result? Well, one's going to have to be positive and one's going to be negative. Factors of 5 are 1 and 5, so I could have -1 and +5. Or I could swap these signs around and I could have +1 and -5. Adding these pairs of numbers up, with the first two I get +4, but with the second two I do get -4, which are the two I need to use. Therefore, this is going to be factorised as x plus 1 and x minus 5. Alternatively, you could have written this. So you can change the order of those brackets, but you must make sure the positive and negative sign are with the correct numbers, so when you add them up, you get that middle term here. Okay, this question over here is a bit more challenging. We didn't look at it explicitly yesterday, and you have actually seen if I was to add a 0 equals 0 here, you could solve this. You would move the 100 across to isolate x squared, to leave me with x squared equals 100, and then you take the square root of both sides, which would give us x is equal to positive and negative 100. But that's not what we've been asked to do here. What we've been asked to do instead is to factorise it. Now, some of you would have recognised this as what we call the difference of two squares. It's a difference because it's a subtraction, and it's two squares because x squared, well, that is squared, it's got squared right there, and 100 is a squared number. So when I factorise the difference of two squares, what we get is a bracket with the square root of the first term at the beginning of each bracket and the square root of the second term at the end of each bracket. So I've square rooted x squared and got x and popped it there and also there, so it's at the beginning of each bracket. And I've square rooted 100 and I got 10, that goes at the end of each bracket. One of these must be positive and the other one must be negative. Expanding this, I'm going to show you why this works. If I was to expand this using FOIL, I get x squared, then outer I get minus 10x, then inner I get 10x, and last I get minus 100. I'm going to have to put that on the next line, I've run out of space there. When I simplify this, these two terms here, they cancel each other out. Positive 10 and negative 10 leaves me with no x. So I end up with x squared minus 100. So where you see the difference, that's the subtraction of two square terms, I can take the square root of each and put them into brackets, make sure that one is positive and one is negative. Okay, I'm going to load up the rest of your answers now so you can check the rest of the questions yourselves. Okay, in today's lesson, I do apologise for having not changed the date. It will now be the 8th when you are taking this lesson. Can you please write down into your book today's date, title and the key words? And also have a go at those two questions on your mini whiteboards. I'd like you to find as many solutions as you possibly can. Okay, for question A, you could have had 2 and 5. They would multiply together to give me 10. I could have had 1 and 10. They would multiply to give me 10. Now, I didn't state that these had to be integers. I didn't state that they had to be positive. You could have had -2 and -5. They would multiply to give me +10. You could have had a half and 20. Okay, they didn't need to be whole numbers. So you could have had lots and lots of options, and what you would have found eventually is actually there are infinite solutions to this. I could keep changing them ever so slightly. I could have 1/4 and 40. I could have -1/4 and 40. I could have 0.2 and 100. That would also work. Sorry, 50. Not 100, 50. Okay, there are infinite solutions to that first one. Now for the second one, I want two numbers that multiply together to give me 0. Well, I know that any number multiplied by 0 will equal 0. So I could have that x equals 1 and y equals 0. If I now change x and make it 2, I would still need y to be 0 to be able to get an answer of 0. What if I made y a number? Let's make it 3. Well, the only number I can multiply 3 by to get 0 would be 0. So there are infinite solutions, because where I keep y as 0, x can be absolutely any number. It could even be negative, it could be a fraction, it could be a decimal. But y must remain as 0, or else I could opt to have x as 0 and then y can change. So there are infinite solutions, but as long as one of them is 0, it will work for the equation. So if I give you a quadratic equation now like this, and I want to know the solutions, well, because we've got x squared in here, this tells me that there are potentially up to 2 solutions. There might also be 1 or even none, and we will look at lessons later where there are no solutions to this and explore why that's the case. But if I can express this as a product of factors, which is what this is over here, this is a product of 2 numbers, a product of factors of 10. If I can express this as a product of factors, if I can factorize it and set it equal to 0, as long as either this bracket here equals 0 or this bracket here equals 0, that will give me solutions where this whole thing here is equal to 0. So if I can factorize it, and if one of those factors is equal to 0, then that will give me a solution to the equation. I'm going to show you what I mean on the next slide. But before we do that, can you please write down these 2 key points into your book? When we are using the factorizing method to solve quadratic equations, the equation must equal 0. If it doesn't equal 0, you will need to rearrange it to make sure that it equals 0. So before we go any further, I'd like you to pause the video here and write down these 2 key points into your book. Okay, so I've got that question again. I said if I can factorize this, if I can write this as a product of 2 numbers and set it equal to 0, that will help me solve this. So the first thing I want to do is factorize this quadratic equation. Well, we've done lots of this. I want 2 numbers that multiply to give me +5, and I want them to add together to give me 6. Factors of 5, well, there's actually only one pair. It's going to be 1 and 5. They will add to give me 6. So that means in the factorised form, I get x plus 1 and x plus 5. That is still equal to 0. So far this is nothing new. You've factorised the equation and you know how to do this up until now. What I said was, if one of those brackets is equal to 0, that will make the whole thing equal 0. So if we said that this part here is equal to 0, it does not matter what this number is. It could be any number in the world. It could be negative, positive, a fraction. As long as this one is 0, overall, this will all equal 0. But also, if I decided instead to make the second bracket equal to 0, so this time x plus 5 equals 0, it doesn't matter what number is in this bracket anymore because it will still equal 0. So what I've now created is 2 equations. 2 linear equations which you know how to solve. I want to rearrange these to find out what is x when this whole thing equals 0. Well, if I subtract 1 from both sides to isolate x, I get that x is equal to -1. On the second equation, if I subtract 5 from both sides, then we get that x is equal to negative 5. So when x is negative 1, that makes this bracket here 0, because negative 1 plus 1 is 0. Okay, so when we substitute this one back in, we get that negative 1 plus 1. That goes into that bracket. The second bracket, well, that negative 1 is still there, and it's plus 5. This first bracket becomes 0. This second one becomes 4. So I'm left with 0 times 4, which does in fact equal 0. If I was instead to do the other one and substitute it in, let's see what happens. If I instead substitute in x is equal to negative 5, what do I get? Well, in the first bracket, I get negative 5 plus 1. And in the second bracket, I get negative 5 plus 5. What I've now got is negative 4 here times 0. Well, that is going to give me 0. So when trying to solve a quadratic equation like this, where it's not simple to just isolate x squared on its own, we can factorise it, set each factor equal to 0, solve for x, and that gives me my 2 points where the equation equals 0. You could even, if you wanted to at this point, and I am running out of room, but you could factorise each of those numbers into the original equation we had and double check it. Can you please pause the video here and write this down as an example? Okay, and can you please try and have a go at the one on the right? So I want two numbers that multiply to give me 24, and I want them to add to give me 10. Factors of 24, we can have 2 and 12. We could also have 6 and 4. There are some more, but I'm going to stop there because I've noticed that 6 and 4 will add to give me 10. So when I factorise it, I get x plus 6 and x plus 4. This is still equal to 0. That is the same equation, I've just factorised it now. For this to be true, one or the other bracket, even potentially both, need to equal 0. So if I set each of them separately equal to 0, I know that one of these has to be the case. Rearranging, I get that x is equal to negative 6 and x is equal to negative 4. Those are the two solutions to this equation up here. If we consider that on a graph, if you think back to our first lesson, we discussed that when you have a graph of a quadratic, it can be in a few different places. It can have one solution, which is a graph that looks like this. There is one point where the equation hits the x-axis, and that's where it equals 0. Okay. Alternatively, we could have two places where it cuts the x-axis, here and here. This is an example of this graph that we have here. It crosses the x-axis at x is negative 4 and x is negative 6. It's not drawn very accurately, but that is where it crosses. Alternatively, you could have a graph that looks like this. This one has no solutions, and we will look later at how you discover ones that are going to be like this. It has no solutions because it does not touch that x-axis. Okay, I'm going to solve this one for you now. We have two numbers that multiply to positive 25 and add to give me negative 10. Therefore, I know that I'm going to have two negative numbers because any positive numbers are not going to create a negative number when I add them. And they are going to be either negative 1 and negative 25 or negative 5 and negative 5. The only two numbers here that add up to negative 10 are negative 5 and negative 5. So these are my two numbers that I want to put in when I factorise. So I'm going to end up with x minus 5 and x minus 5 equals 0. Now when I answer this, we're going to have x minus 5 equals 0, and I'm only going to write it once this time because it would be the exact same thing. Therefore, this equation equals 0 when x is equal to 5. Okay, as I said, sometimes you will find there is only one solution, and that's because in this case, this is a repeated solution. If I was to draw this on a graph, it looks something like this. It touches the x-axis where x is equal to 5, so that's the number 5 just there, and it just touches it and bounces up off of it. It will also go through the y-axis, and just like with a linear equation, this number at the end tells you where it crosses the y-axis. That's the y-intercept. So this graph, if I was to graph it, looks something like this. Now this point here where it crosses is at 25. For now, you don't need to be too worried about how it looks on a graph. You mainly need to be focusing on actually solving it. This is just to give it some context. Can you please write this one down as an example? And in a moment, I will give you one to try on your own. Do apologise, the answer has come up there already, but can you please have a go at solving this one on your own and think carefully about the steps that you will follow each time. And you may have in fact noticed that my answers are completely wrong. I do apologise about that. We're going to have x equals 12 and x equals 3. On a graph, that would look like this. It goes through at 3, and it also goes through at 12 on the x-axis, and on the y-axis it goes through at 36. The 36 is just here. This is not drawn accurately, and it's just to give you some indication of how it looks. Okay, we could also be asked to use the factorization method to solve questions like this. Now, on our first lesson, you guys would have isolated x squared by adding 25 to both sides to get x squared equals 25. You would then take the square root of both sides to get that x is equal to positive and negative 5. You could also be asked to factorise this. To do this, you need to notice this, just like in our challenge in the do now, this is a difference of 2 squares. So I square root the first term, and that goes at the beginning of each of my brackets. Then I square root my second term, and that goes at the end of each bracket. One of them is add, one of them is subtract. This is still equal to 0, so one bracket at least must equal 0. Sorry. And now I get that x here is negative 5 and x here is positive 5. So you still get the same solutions whichever way you do it. Please pause the video and write this down as an example. And please have a go at the question on the right. And there is your solution. Okay, please pause the video here for each mini whiteboard assessment question and have a go on your whiteboard at these questions. Some of them I will solve for you, others I will just reveal the answer. There's the solution. Next question. Have a go at this one. There's your answer. One more. And there's your answer. Okay, can you please pause the video here and have a go at these questions? I would like you to show me all of your workings, and starting today for maths, we are going to start asking you to, as well as the frog quiz, to upload a photo of your work. Therefore, you need to be answering these questions into your book because your teacher will be checking that you've uploaded a photo. Okay, for those of you who have finished, or you may have got to question 15 and 16 and got a little bit confused. Remember, right at the beginning of this lesson, I told you that your quadratic equation must equal 0. Therefore, you need to rearrange both of these to get this part here equal to 0. To do that here, I need to subtract 5 from both sides, which will recreate a new equation of x squared plus 12x minus 45 equals 0. Now you can just follow the same method that we had. So if at this point you had got stuck, I'd like to try and have another go at that one. And for question 16, to make this equal to 0, I need to subtract 2x, and I also need to subtract 35 from both sides. That is going to give me x squared. I've now got minus 3x minus 108, and that is now equal to 0. Now that those both equal 0, you can have a go at solving them. Okay, here are all the answers. Okay, you have come to the end of today's lesson. Can you please make sure that you upload a photo of your work using the file drop button, and you also complete the online quiz on Frog.